Good day, everyone. Welcome to Tutors once again. We're starting a new series on sedimentary depositional environment. Okay, so in sedimentary depositional environments, topics we're going to cover are alluvial, the fluvial, the lacustrine, the aeolian. Um, so these are more of continental and into like the transitional part, but basically more of the continental sedimentary depositional environment section. Okay, good. So first, when we talk about depositional environment, there's a terminology that will actually be repeated over and over again throughout this course and throughout the series of this course. And that is what we talk about, the facies. Or I say facies, Facies. Now, what is a facie? A facie can be defined as the sum total characteristics of a rock, be it physical, chemical, and biological, that distinguish it from its adjacent rock. What does that mean in layman term? It simply means that if we say this is a facie, we are saying that it must be different from the characteristic of another rock, adjacent rock. This is rock B, this is rock C. So the facies, which means the characteristic of B, is there from characteristic of C. Let me tell you, funny thing is that B and C can both have the same lithology. That means this guy can be sandstone and this guy can also be what? Sandstone. Okay? But the issue is that facie, based on where it's being deposited, the physical characteristic or the chemical characteristic or even the biological fossils, the fossils that can be present in C, might be on the fossils that can be present in B. So that is why facie is particular and streamlined to just a specific depositional system. So a sandstone deposited in probably an alluvial setting or in a fluvial setting, then from a sandstone that is deposited in the lacustrine setting. Good. Even though they are both origin, their facies characteristics are different. Okay, so let me just give a simple example. This guy here can be red in color. The color here can be red and here can be blue. Okay, so this red sandstone, blue sandstone, they are different. They are of different facies. They are of different facies. So facies are the sum total characteristic of a rock, be it physical, chemical, and biological, that distinguish it from its what? Adjacent rock. Another terminology that we need to understand is the Waters law. Waters law of facies succession. This law is very, very important even in stratigraphy. Okay, it states that an environment that succeed each other vertically, okay, laterally we do so vertically, or vice versa. What do we mean by that? So for example, we're talking about Waters law of facies succession, right? So if probably we have like a system here, right, and here is the water body. Can you see that? Here's the water level, the sea level, right? Good. Now we have probably here we have silt, just for example. Here we have sandstone, and here we have shale. Okay, good. You can see that the deposition of these guys, their relation is laterally. Huh? Is laterally. Lateral relationship. Can you see that? Lateral relationship. Lateral relationship. Now, if this sea level, if it transgresses, what's going to happen? When it transgresses, means when there's an increase in the sea level, as increase in the sea level, this layer of rock, of silt, will move up. This layer of sand will also move up. So you have something like this next. So, sorry, let me draw it very well. This layer will move. You know, we have this guy here first, have we? The silt. So the sorry, this guy like this, right? So we have this guy here, the plus. So it has increased, right? The water level has increased. Now, if you're going to have the facies of this guy moving upward, this guy moved upward. So this guy moved upward. We have the silt. We have the silt. Then after the silt, then we have the sandstone, right? So something like this. Let me draw it again so it will be clearer. So first, remember that we have this rock mythology in this place. Then next, you're going to have fall down because the sea level increases. This guy that was here laterally will move up. So we have this sandstone here. Then the last one that is here, the silt, we also move up. So if you do a bore in this region, what you are going to have is a vertical relationship. It's a vertical relationship showing us the relationship between the sandstone and the what? And the silt. So that is just a brief explanation or diagrammatic explanation on our Waters law of Facies succession. Waters law of Facies succession. So, but there's an exception for this rule, in that for this rule, this law can be broken when we have an unconformity or hiatus. So let me explain something to you. If we say we have a Facies model, we're talking about a particular pattern. You can see we have A, B, C. So we're saying that if we say this is a Facies model, that means if we define something as a Facies model, we're saying we have A, B, C, right? Means after A, what must follow must be B, and what must follow must be C. Okay. So if you reach a rock and you want to log the kind of log in that kind of environment, and you saw A and C, let me tell you, they are not of the same Facies model, because you did not see B in the middle. But let me tell you, if you have A and B, they are of the same Facies model. A and B is same Facies model as what? A, B, C, because they follow each other vertically, even though there's no C there. So A, B, A, B. So they must follow a kind of pattern. We'll still come into that next video. So in next video, we're going to move into our first depositional environment, which is the alluvial depositional setting. So stay tuned, share my video to your friends. Thank you. Stay tuned.